A precipitation reaction. Precipitation reactions are very, very common in chemistry. And the word precipitation does not mean rain in that sense. It means forming a solid when you mix two solutions. That's what it means. So it's based on a double replacement reaction, double replacement or displacement, as you saw earlier in this lecture. And it causes the formation of what we call a precipitate. We usually shorten this with PPT, and that's basically an insoluble solid. Interestingly enough is that it usually appears like magic. You're taking two clear solutions, really, really clear solutions. There's nothing in them. And as you start adding them, a solid forms. And we will show you in the next page. But one thing to remember is that in precipitation reaction, since it's a double replacement, it appears to exchange ions. There's an exchange of ions in that reaction. Here's an example. You mix potassium iodide with lead nitrate, lead 2 nitrate. You can verify these. You should be able to. You can pause and verify that these are both soluble. Both are soluble from the solubility table. So they are two clear liquids. Look at them. Because you have, again, potassium. You're adding it. There's potassium and iodide dispersed in solution, 100%. You also have 100% of lead and nitrate right there. But what is happening is as you start adding them together, watch here, a yellow solid forms. A yellow solid forms. It's like out of nowhere. Well, what happened here? Well, a precipitate formed. This yellow material, that's a precipitate. This yellow solid that is forming. And what is happening here is if you look at those colors, because visualization is very important in this class, if you look at this, you'll see that the lead found its way to the iodide and it formed a solid. Again, lead found its way to the iodide and it formed a solid. However, nitrate and potassium remain right here, remain in solution. They remain as ions. So here you have a combination of a solid and a aqueous solution. So here it is. What happened is potassium iodide is your precipitate. So this is what we call a molecular equation. Molecular is just simply you write the entire equation. What are you supposed to do in this? You're supposed to be able to write the products, which you're about to learn that, and of course, write something much more important than just writing the products called the net ionic equation. Very well. There's one thing you need to remember is that just because you have two ionic compounds mixed doesn't mean the reaction takes place. By saying a reaction takes place, we mean a solid forming. But if there's no solid, no precipitate forming, then that's a no reaction. So again, the reason why it's no reaction because there's no precipitate. Very easy to demonstrate that. K, I, K goes with the Cl. And the Na goes with the I. We're going to learn how to do this, but the product should come out to be, let me rewrite the whole thing, Ki AQ plus NaCl should give you KCl and NaI. The interesting thing is that both of these are soluble. You don't believe me? Let's check the solubility table. So let's look at Ki and NaCl. We had Ki and we had NaCl. So here's Cl and here's the I. It's I minus. They're both soluble compounds. But is K plus one of the exceptions? So that's what we began with, remember? Is it any of the exceptions? Nope, not neither Ki nor Na. Now the products that were formed were KCl and NaI. Same thing. Here's Cl. Is K one of the exceptions? Nope. Still a soluble. And Na is also not an exception for I minus, so therefore they remain soluble. So if you're mixing just two solutions that again are in ions and there's no chemistry occurring between them. So that's a no reaction. If you get two soluble compounds, no precipitate, then you have a no reaction. You should not write the products, you just write no reaction. In the next video, you will learn how to do net ionic, how to work on writing the net ionic equation.